This is Geometry 4.2. We're going to talk about rigid motion, otherwise known as rigid transformation, and congruence. So when we look here at this Audi, it looks like the Audi's driving through. It's doing a translation. We're sliding the car off to the side. The same size and shape. The tires are the same. The windows are the same. The lights are the same. Even though it's moved over, it's still the same automobile. It's still this congruent to each other. Down here we have the Ferrari, and it looks like it's spun around. It's done a rotation. It has a different orientation, but it's still congruent to each other. It looks like it's going in a different direction, but it can still be congruent. So when we look at geometry figures, we can have the same idea. Here's a translation. We're taking this triangle and we're sliding it over to the side. So what I've done, I have traced out this triangle on the tracing paper. I've labeled it ABC, and I slide it over to the side. And we can line it up, and you can see that the angles are still the same, the segments are still the same as triangle GEO. So we would call that congruent. They are the same size and shape. What do we notice about the two triangles? Same size and shape. We would call that congruent. What type of parts is a triangle made of? What would you say? What's a triangle made of? Three sides or three segments. And what are the other things that are created by the segments? We have three angles. So that's what we need to look for when we talk about triangles being congruent. We need to be sure the three sides match, and we need to verify that the angles are even the same. When we look down here, and we take our triangle, we traced out triangle ABC, and I slid it over so that the A lines up with the G. So if you notice, the A is congruent with the G. The B is congruent with the E, and the C, angle C, is congruent with angle O of this second triangle. So angle A was congruent to angle G. Notice we don't use the M for measure. That's only when we work with equality, the measure of angle A. We also talked about angle B. Angle B slid over and it became angle E. They were congruent. And C was congruent with O. So we have all three angles equaling. What we call those are corresponding parts. A was congruent to its corresponding part. When it slid over, what did A map onto? So when I use my tracing paper and we slide it over, the A mapped onto the G. The B mapped onto the E. So those would be considered corresponding parts. Segment AB, this left side of the triangle, is congruent with what segment in this triangle? GE. Segment BC, the one down here at the bottom, as we slide this over, what does BC map onto? EO. And then the last one, CA, is congruent to OE. And notice that we put a bar over each one of those. So this is segment BC is congruent to segment EO. It should be OG. I'm glad you guys were thinking. I think so. So those are our corresponding parts. The three angles are congruent to each other, and the three corresponding sides are congruent. It's important to use the word corresponding sides because all three sides aren't congruent, but the corresponding ones are congruent. The ones that map onto each other. As we slid this triangle over, how did it line up? The BC became the EO. So when this happens, we do something called a congruent statement. And this congruent statement idea is really important. We're going to use this congruent statement in the future for the next several chapters. This says that the congruent statement is triangle ABC is congruent to triangle GEO. This is called a congruence statement. Notice that this type of statement is not if-then. This is literally triangle ABC is congruent to triangle GEO. And it's kind of neat because angle A is supposed to be congruent to angle G. So notice that they're in the same exact position in the triangle name. That the A was first and the G was first. B was congruent to E. B was written as the second letter, so the E was written as the second letter. C was written as the third letter, so O was written as the third letter. So order matters. And then what else this tells you? Are the segments. Notice that AB are the first two letters. GE are the first two letters. AB and GE. BC were the last two letters. It's congruent to EO, which are the last two letters. So the order of the congruent statement matters. CA were the last and the first. So OG is the last and the first. So the corresponding parts have to match up. So this is one of the possible congruent statements we could write. We could change the order of the first triangle. The first triangle can be written in many different ways. There's actually 6 ways to name a triangle. That was one way. If I change the B and the C, now I have a different name for the triangle. So my congruent statement has to follow it accordingly. So A correspond with the G. I know that C is supposed to go with the O. So O has to be the middle letter. And B corresponds with E. B is congruent to the E. So if B is last, E has to be last. You could write a congruent statement that starts with B, BAC. So what would be the order of the triangle if the first triangle is written as BAC? B corresponds with the E. So E has to be first. A corresponds with G. And C corresponds with O. triangle BCA is going to be EOG. So if we change the last two letters, we got to switch flop the last two letters. So what this is showing you is that the order of the letters of the first triangle can be in any pattern that you like. What's cool about a triangle is you can't name it incorrectly. You can name a square incorrectly, but you can't name a triangle incorrectly. You have to go around a figure. In a triangle, you can't shoot through the center because there is no vertex across from another vertex. But when you have a four-sided figure, you can't go crisscross when you're naming it. You have to go in a circular motion. That's going to happen every time you try to name a triangle, in a circular motion. So CAB, C corresponded with the O, A corresponded with the G, and B corresponded with the E. And the last triangle, what way have I not named the triangle yet? I started with A, I did both of those ways. ABC was named that way originally. Okay, starting with C, every triangle you can name a triangle going clockwise or counterclockwise, starting at any of the vertices. So OEG. So those are 6 congruent statements. Normally you will only write one congruent statement, and any of those can be appropriate answers. Okay, on our next page, we have plotted out. Now, these plots didn't work out great. So I'll darken in this line so that we know that that's going to be our y-axis. And this point is A, and this location is D. So the lines really aren't lining up great with it. But what we're going to do is slide it over. Actually, we're reflecting it over. We're reflecting it over the y-axis. So when we reflect it, we're going to count our lines. So we count the number of lines that it takes to get to the y-axis. 1, 2, 3, 4, 5. So we're going to go 1, 2, 3, 4, 5. D is going to go 1 to get to the line of reflection, so we go 1 past the line of reflection. This would be B, so this would be C. C is 1, and B is 5. So here is our new shape. And our new shape, the A corresponds with the M. So if we reflected it over, we counted 5 to get to the line of reflection and 5 to get past it. So M would be here. O, T, and H. D is going to become the H. D was 1 unit away from the line of reflection, so we have to go 1 past that to become the H. So our corresponding parts. We know that angle A was corresponding, and in these cases they're going to be congruent to angle M. Angle B is corresponding, and in these cases is going to be congruent to angle O. Angle C is congruent to angle T, and angle D is congruent to angle H. In terms of the sides, AB is going to be congruent. If it reflects across, if I trace this out, if you notice, I traced it out, A, B, C, D, and I reflect it over this line of reflection. So the AB is now way over on the other side of the triangle. It's become MO. BC, segment BC, becomes OT. CD is congruent to TH. And segment DA is congruent to HM. Notice we put our segment bars over each of those. So a congruent statement that we could write would be A, B, C, D. That's how we name a four-sided figure. You're going to go in a circular motion. You have to go consecutive angles. You can go either direction. That doesn't matter. You just cannot say ACB. You can't go through the inside of the shape to get to another vertex. You got to go around it, the outside. That's going to be congruent to MOTH. You can start at a different vertex. You can start at B. And you can go around counterclockwise. BADC. And that would be congruent to OMHT.